All right, welcome everybody to our last unit. This is the wrap up for the year. Just a reminder, real quick, we will be starting to review for milestones on Wednesday. We will start with Unit 1 and we'll carry on there until we go to spring break. And we come back from spring break, we'll pick up until we get ready to test for milestones, which begin on the 23rd of April. Uh, so let's kind of get to this and see what's going on with our mini Unit 6. All right, so when looking at these, we're looking at types of associations or correlations. In other words, how do these two dots, how does my data set, how do they relate to each other? Well, if I'm looking at this data set, I notice that it's falling. If I'm reading the graph from left to right, it is falling from left to right. So that means it should be going downhill, which would be a negative slope. Okay, and then if I want to determine whether it's strong or weak, what we can do is we can kind of put our oval around this. And if you want to look here, if you'll notice if I enclose this one, it does kind of change the data just a little bit. So what I'm going to do is I'm going to kind of back up just a little bit because I want to talk about that one dot. Okay, that one piece of data. But if I look, I notice that my oval is very flat. Okay, that means that my data is very strongly related to each other. It means as whatever's going on this x-axis, as it's going up, the y is coming down by the same rate. Now this guy right here, the one that's kind of outside the data range, we talked about this one. We would call him, or that data set, a outlier, which means it lies outside of the normal data range. Now this one really is very close. Normally an outlier is going to be very obvious, way off to the side, either above or below the normal data range. But I kind of just went ahead and did that one just to show you to remember that it is a one that's not part of the normal set, whatever this data range is. Okay, all right. For this next one, we are kind of going to do the same thing. But if you'll notice, nothing is really kind of out of the ordinary here. Everything's kind of tightly packed. We're going to say this one is, I'm going to still say this one, even though it looks kind of big, it is a flat oval. And since it's rising from left to right, remember we read graphs and we read them from the left to the right where my data starts low and it ends up high, then this one is going to be a positive correlation or a positive association. And since we said it was flat, we're going to still say this one is strong. Okay. If I look at this data here, I really can't tell. Remember, when it's one of these data, I really don't know what it's doing. I don't know if it's going up. I don't know if it's coming down. I don't know if it's staying flat. And I don't know if it's really vertical. So here, if I do this one is not really an oval at all. It's a circle. So this one would tell me I have no idea. So that's really a no correlation or no association. There's no discerned pattern that I can tell which way that my data is going. Okay, plus it's a circle where these two were ovals. Okay, so positive association, negative association, and no association are my three types of data. Okay, so let's kind of look at this now. I don't have anything here. We're just going to kind of look at, go off intuition. The amount to eat and your weight. Generally, what we're saying is the amount you eat, does it affect your weight? Generally, as it does, it is a positive association, because what you have here, as x goes up, these are your two categories, x and y. X is going to increase, y is going to increase. So both of your categories will increase, so that is positive. The amount you purchased and the money left in your wallet. Well, the number of items you purchased is going to go up, so one is going to increase, and the money left in your wallet is going to decrease, so one is going up, the other is coming down. That one would be a negative association. As x increases, y decreases. Okay. The color of your hair, so color of hair and speed you run. Well, really, the color of your hair has no effect on how fast you run, and how fast you run has nothing to do with the color of your hair. So this one would be a no correlation or no association. They're not going to go together. Okay. So just remember, as one goes up, the other one goes up. It's positive. So both of them are going in the same direction. One goes up, one comes down. That's negative. And then when neither one of them can really tell you what's going on, that's no association. All right, line of best fit. Remember, the line of best fit has 4 rules, really. The first rule is your line must follow the data. Okay, whichever way the data is going, that's the way the line needs to go. And by saying that, what I mean is, if I draw this line, right, it's pretty good trend, but is it really following the data? No. Okay. Uh, this one's the same way. It's following the data. It has a positive slope, but it's not really going with it, so that's not really a good one. Okay. So it must follow the data. You want to pass through as many points as possible. Pass through as many points as possible, all along the line. Okay, you want to kind of go through different points. Okay, so we could draw a line that goes through the middle. Okay, so we want to pass through as many points as possible. You don't have to touch all the dots, and you're not going to touch all the dots. But you want it. Sometimes you may not touch any dots, but in this case, we would touch some. The third point was the one we talked about, was really the most important one. What you're trying to do when you draw this line of best fit is you want to try to cut the data in half. So you really want an even number of dots or data above the line. And I'm going to back this up because that writing is not too good. Okay, above the line of best fit and below the line of best fit. What you're trying to do is you're trying to cut the data in half or split the data. Okay, so if I'm drawing this line, what I want to look at is I want to say, all right, what can I do to draw this data, cut it in half? So if I'm drawing, I want to draw something like this, and again, I'm following the dots. Okay, and I really could kind of probably do a little bit better than that. We can probably go something like this. Let's see. Yeah, that looks a little bit better. Not much of a difference, but it's a little bit better. So if you look, most of my data, no, I still don't like that one. Let's try one more. Let's try just a little bit better. There we go. Okay. So now I have a lot of dots here, but it kind of compensates here. So my data is pretty much split in half. Okay. So the whole key is try to cut the dots in half, cut the data in half. Okay. And what you may have, I don't know, what you may have is you may have 3 or 4 choices. Okay, that green one is following the data, but if you look, the majority of the dots are below. This yellow, even though it's following the data and it has cut it in half, it's not really going in the same direction. This last one, this one really splits the data in half. But I know, and I'm trying to draw a zero slope line. I'm trying to draw it kind of flat because I don't want it to be. I want to show you the difference, and I know my line is not perfect. But what I want you to see is, even though I did split the data, this one, the green one, and the yellow are not really following the line. Okay, makes sense? All right. Write an equation. This one's kind of hard to write an equation because it's really hard to pick up on the 2 dots to actually find your slope. So what you can do with this one, we can say we know it crosses by a dot. We know that the red one crosses somewhere about 0.138. Okay, so we added that. So that's my y-intercept. Remember, all you're looking for is your slope and your y-intercept. Well, I'm going to kind of, since these numbers are going up by 0.1, so we have 0.5, 0.5, 0.45, 0.50, 0.55, 0.60, 0.65. We're just going to say something over, we don't really, it's kind of hard to tell with that many dots, so we're just going to say x over 10. Don't get caught up in so much of that. Just make sure you can split the data in half. That's the whole key. This problem right here, this part of the problem, this part of the step is to make sure we can do that. Okay? All right. So let's look at true or false. The line of best fit must be altered, moved, or curved to fit through all of the points. Well, we know right up here, you have to pass through as many as possible, but not all of them. Okay, don't ever try to move the dots. Don't ever try to move your line to where you have to touch every dot, because then you're not going to have a straight line. Okay, so that's a false statement because we're not going to touch all of them. Points that are far away from the line of best fit are called outliers. That is absolutely true. Those are the ones that lie outside of the normal data range. Well, a possible one in our graph above. whatever this data is right here, if I was to put a dot somewhere right here, whatever this is, I don't even know the categories, it doesn't matter. All I know is this dot is different from all of those because it lies outside of the normal range. Same thing you could say about a dot, say right in here. Whatever this x coordinate is, x value is, it's not very high on the y-axis scale, so it's kind of different from the other dot. It lies outside of the normal data range. Points that are far away are called wayouts. Well, we just determined that they're not called wayouts; they are called outliers. Okay. If some points are not on the line of best fit, they have been graphed incorrectly and need to be plotted again. Okay, that is false. Don't change the data points. The data is what it is. You can't change something just so, just kind of like the example we gave in class. If 10 people ordered 20 hot dogs, that is a fact that you can't change by just making it to want it to fit your line. So leave it as 10 people, 20 hot dogs, and then we adjust accordingly. Okay. So that is false. Don't change your data. Your data is what your data is. Okay. The line of best fit is not meant to go through all points so long as they go through many of them. That is exactly number 2 above. Okay, that is a big true statement. So you might want to those 2 true statements right there. Make sure you can understand why they are true. Okay, if all points are on the line of best fit, it's a linear function, not a scatter plot. Well, absolutely. What scatter plot means, your data is scattered out. You are comparing something. But if they are on that line, that is a linear function, so that one is true. Okay, so all the points will be on there will be a true statement. All right. Okay, let's go to the next one. All right, here comes the two-way tables. Now, we worked a lot on these, so all we want to do to start with these, let's go ahead and fill in what we know. All we're doing is filling in the blanks. It's just addition and subtraction. Okay, so we're comparing 10th graders that can drive and can't drive to the ones that have a job and do not have a job. All right. So to kind of go back and recapitulate real quick, let's fill in the numbers first. Well, if this is 100% of the total, 43 of them do not have a job. That means this one is 100 minus 43, which is 57. So the total right here is 57%. Okay, that means that's the total number of students that have a job. Didn't say anything about can drive or can't drive. So let's find out the total number of students that can't drive but have a job. Well, if I do that, it's just 57 minus 46 is 11. So remember, if you're outside in your total and you're going inside, it's a subtraction problem. Okay? If I'm inside right here where I have my 2 joint frequencies and I want to find the total, that's just an addition problem. Okay? So now it's 11 plus 33 is 44. And then check real quick, 56 and 44 should equal 100, and they do. Okay, same thing, I can find this box. I can find the total of students that can drive and don't have a job by subtracting 56 minus 46 or 43 minus 33. Either way, they come out to be 10%. Okay, so now everything is done. So let's kind of talk about what each category means. Okay, this 46% means of the total students surveyed, which I don't know yet what that number is, 46% of them can drive and have a job. 11% of the students cannot drive, but they have a job. Okay, 10% can drive, but do not have a job. Okay, so you see how those are just reverse of each other. Okay, and in this category right here, this is the one we talk about. It's neither. They cannot drive, nor do they have a job. Okay, and then my totals. This 56% is the number of percentage of 10th grade students that can drive. 44 is the percent of 10th grade students that cannot drive. Notice it didn't mention anything here about a job. Okay, so jobs are going to be my row totals. All right, so 57% of 10th graders have a job. 43% do not have a job. Okay, and again, notice it didn't mention anything about driving because we're not comparing. We just want to know who has a job, who doesn't. Okay, all right. So let's look at some of the statements. Some 10th graders can drive and some cannot. Some have a job, some do not. Read the following statements and decide if they are true or false. All right, most 10th graders have jobs. Now, this one did not mention anything at all about being able to drive. All it wants to know is to compare the number of 10th graders that have a job. Well, if I look right here, 10th graders that have a job is what? 57%. 10th graders that do not have a job is 43%. So that one is true because you have 57% do and 43% do not. All right. What about 10th graders that can drive? Now, notice it doesn't say anything about having a job. All it wants to know is how many can drive. Well, if I look right here, how many 10th graders total can drive? That box is right here. That's 56. And then the total for that can't drive is 44. So according to my statement, most 10th graders cannot drive. That is a false statement. Okay? It is false because only 44% can drive, while cannot drive, while 56% can drive. Okay? So you see, all you're doing is making that comparison. What is it asking you? All right? Most of the 10th graders who have jobs can also drive. All right, so now all I'm looking for now is I've locked myself down into this category. All I'm looking for is the 10th graders that have a job, which is right there. Okay, so let's talk about what they got. So most of the 10th graders who have a job can also drive. Well, if I look at 10th graders that have a job, that's 46% that can drive, while only 11% of those cannot drive. So that is a true statement. 46% to 11%. Okay? So again, just take your time and read what it's asking you. Okay? All right, now, what I need to look at this next question. If there are a total of 1,050 10th graders in the school, how many have jobs and can also drive? Okay? So what this is asking me is, really, the 6th grade math is asking me things you've done before. What number is 46% of 1,050? Because 46% can drive and have a job. So I want to know the actual number instead of percent. So what number is 46% of 1,050? And the way you answer that is just 1,050 times. Now on our calculators we have the percent button, but if you don't have it, it's times 0.46. Well, if I pull that out of my calculator, I should come out with 483 people. Or 483 of the 10th grade students can drive and have a job. 483 10th graders have a job, and let's back this up. 483 10th graders have a job and can drive. Okay, so that actually would be this number right here, 483. Okay, all right, questions 20 through 25. We're looking at this table. It wants to know, we're comparing now boys and girls to the number of boys and girls. Some of them have pencils, some of them do not. So you're comparing now two quantities here. Well, what I noticed right off the bat is the first question is how many students were included in the data. Well, I don't have a total set up yet, do I? So what we're going to do is we're going to create a total category. So remember, tomorrow on the test, if you have this type problem, go ahead and set up your two-way table. Go ahead and finish out the two-way table, I should say. And let's find all of our totals. Okay? So then we can make our predictions. All right, so if I'm looking here, the total number of boys. Don't care whether they have a pencil or not. All I know is the total number of boys is 44. The total number of girls is 52. All right, which should be 44 plus 52 is 96. And if we do this right, then this total here should come out to be 96 as well. Well, of the students surveyed, 33 have a pencil, 27 have a pencil, that's 60. 11 boys do not, 25 girls do not, that's 36. 60 plus 36 is 96. So as long as these two totals equal these, then we're good. All right, so let's look at our survey. Okay, here's some of the questions. Most girls have pencils. Okay. Now, when I'm looking at girls, all I care about now is once I do that, when I talk about girls having pencils, all I'm looking at now is this category right here. That's all I care about because the survey did not mention boys. It did not mention the total. All I care about is right here. Okay. Most girls have a pencil, so we're looking at the girls. Okay. Uh, Looking at the girls, 27 girls have a pencil, 25 girls do not. Okay, so that one is true. 27 do, 25 do not. Okay, all right. Most boys have pencils. Well, now if I'm looking now, most boys have pencils. Okay, boys have pencils. So what I'm looking at now is, again, I'm in this category right here. I don't care about anything else. All I want to know is the boys. Of the boys, what do I have? It didn't mention anything about girls. So right now all we're looking at is boys. Okay, all right. So if I look at this category, 33 boys have a pencil, 11 boys do not. So most boys have a pencil. That is true. 33 do and 11 do not. And let me fix that 25. Let me fix this too. Okay. So that was 25, right? Okay. All right. More girls than boys have pencils. Okay. Again, so all I'm looking now is this category right here. Now I'm talking about just having pencils. Now we're going to compare the boys and girls that have pencils. Well, now I'm locked myself into this category. So that's the number I'm looking for here. Well, if I look at that category, then I can say, okay, let's, what do we have? We have 33 boys that do and 27 girls that do. So this one is a false statement. Okay, 27 girls do, but 33 boys do. Okay, so we have more pencils for boys than girls. More girls than boys were surveyed. So here we're looking at the total. So the total of girls is 52. The total of boys is 44. That one is a true statement. 52 girls and 44 boys. All right. What percent of students with pencils are boys? What percentage of students? Now this is the one you need to watch, right? Because this one now is asking you, when I see that percent, I'm thinking fraction. I've got to create a fraction somehow. So when it says what percent of students with pencils, okay, remember that first part usually tells me my denominator. The second part usually tells me my numerator. But if I'm keying in on this, what I'm looking for right now, what percent of students with pencils? So it's asking me for the total that have pencils, right? What percentage of students have pencils? Okay, so now I'm knowing this category. And if I look, the number of students that have pencils are 60. Let me move that down just a little bit. Okay, so we know it's out of 60. Well, how many are boys? 33 boys out of the 60 total. Okay, and if I put that in my calculator, I should get 0.55, which, remember, if we can change it to a decimal or move our decimal 2 places to the right or multiply it by 100, we should get 55%. Okay, so 55% of the boys have pencils. Excuse me, rephrase that. 55% of the students that have pencils are boys. Okay, so this would be 55%. All right, let's see if I can think of a couple more to ask you. Let's just see. What percentage, I'm just going to make this up. What percentage of the people surveyed, what percentage of the students surveyed are girls that do not have a pencil? What percentage of the students surveyed? So what percent of the students surveyed are girls that do not have a pencil? Okay, so if I look at this, what percent of the students surveyed are girls that do not have a pencil? Okay, this is wanting to know out of the total. So here's my total. So my fraction would be 96, and girls that do not have pencil is 25. Okay, so let's see what we have here. So we take our calculator and we put up there 25 divided by 96 gives me 0.2604. And if we move the decimal 2 places to the right, okay, if we're sitting right here, move the decimal 2 places to the right, so it'll be 26%. Okay, so 26% of the students that were surveyed are girls that do not have a pencil. Okay, so just read the category through. All right, let's try one more. Let me see if I can make up one more. Let's see, what can we do? Okay, what percent of the boys have a pencil? Okay, what percent of the boys surveyed? And God, I apologize for this. Right? Let me see if I can fix this just for a second. What percent of the boys surveyed have a pencil? Okay, well, if I look, I've locked myself into this category. There were 44 boys surveyed. 33 of them have a pencil. Okay, so again, we take our calculator. 33 divided by 44, 0.75. So 75% of the boys have a pencil. Okay, so just read the categories and set them up. All right, let's do both of those are comparing a joint to a margin. Let's do a margin to a margin. So let's do one more real quick before we go. Let's see, what percent of the students surveyed what percentage of the students surveyed were girls? All right. Well, when we're asking that question, we're asking out of the whole, because we want to know out of all of the students surveyed, what percentage were girls. Well, if I look right here, the percentage of, there was 52 girls out of 96 surveyed. So 52 over 96 would be my fraction. And let's see, 52 divided by 96 is 0.54. And if we move our decimal again 2 places to the right, and if we round up, we'll just 0.542. So 54.2%. Okay. All right. So that's all they're doing is just make sure you read through very carefully, because the filling in the table is not hard. As far as you guys have done an awesome job of that. Just read your sentence, take your time, read through it, and set up the fraction, especially when it asks you percent. That's what it's asking you to do, is to fill in a fraction. Okay? All right. Y'all study hard, and good luck on tomorrow's tests.